Okay, part two. So now he's gonna have to just go graphing a bunch of these and stating the domain and the range. So we start off pretty easy. It's actually, I think, an example from the other side. But what you want to say to yourself is, how is the original point moving? So since usually these graphs look like this, they have a point at 0, 0, and they go like this, how is that original origin point moving? So in this case, we're just moving 2 to the right. The number is inside with the x, so we use the opposite sign, which is positive 2, and we move to the right 2, put that original point. And then to check, you can also go plug in the 1 point to the right, so plug in 3. 3 minus 2 is 1, square root is 1, so I know, there we go, I'm good to go. Okay, I'm gonna graph them, and then I'm gonna come back and do the domain and range. So let's look at number 2. Same deal, x plus 3 means go to the left 3. I can plug in negative 2. Negative 2 plus 3 is 1, square root is 1, perfect. Go ahead to number 3. Now my number is outside, which means I move up or down using the same sign, so up 3. I can plug in 1 for x to see what my next point is, so square root of 1 is 1, plus 3 is 4. There's my graph. All right, this next one's a little weird, but this is the same thing as the square root of x plus 5. We're not really used to seeing it in the front, but it's the same thing as if it was written like that. So it means I'm going up 5. Same thing here, it's written in a kind of weird order, but the number that's outside tells me up and down, same sign. Inside is left and right, opposite sign. So moving to the left 3, and I'm moving down 4. That's where my original point goes. And I should be just going up like this, but let's double check. Let's plug in negative 2. So negative 2 plus 3 is 1, square root is 1, plus negative 4 is negative 3. Yep, that's right there. And then this one, I'm gonna move to the left 6 and up 4. So left 6, up 4. If I wanna go check, I'm gonna plug in negative 5, but I'm gonna get like that. Okay, so now let me do the domain and range of each one. So for this, I'm thinking, for my domain, I'm seeing what's my smallest x and what's my biggest x. Okay, domain is always the x's. So my smallest x is 2, that comes first. And then I'm going to infinity. So as long as my graph is opening this way, I'm gonna always go to infinity, which I think all of yours will. But my domain is from x value of 2 to infinity. This domain is an x value of negative 3 to infinity. So once you go do your domains and then come back and check, this domain is from 0 to infinity. This domain is also from 0 to infinity. The x didn't move. This domain is from negative 3 to infinity. And this domain is from negative 6 to infinity. Okay, now I've got the range. The range some people have more trouble with, but the range is saying what's my lowest y and my biggest y. So as long as my graph opens like this, my biggest y is going to be infinity. My smallest y, though, is how high am I, like up and down. So my lowest y value here is 0. The highest y value is infinity, right? This point is at 2, 0. The y value is 0. Same thing here, my lowest point is at negative 3, comma 0. So my lowest point is 0, my highest is infinity. Here, my lowest point's not 0 anymore. My lowest point, my lowest y, is at 3, right? This ordered pair is 0, comma 3. So 3 is the lowest y, infinity's the biggest. Here, my lowest y is 5. Here, my lowest y is negative 4. And here, my lowest y is 4. Okay, so that's my domain and my range. Now we got a few more on the back to get a little bit harder. Okay, so now he sticks a number out front, and I'm gonna show you what that does. That just makes the number out front in front of x, not, if it's separated by addition or subtraction, that moves the original point. But a number multiplied just changes like how steep the graph is, how fast it gets going. So my original point is still at 0, 0. But now watch what happens when I plug in 1 for x. I get a square root of 1, which is 1, times a half. My y value is only a half. I'm not going to plug in 2 because the square root of that's annoying, but how about 4? The square root of 4 is 2. 2 times a half is 1. So I'm only here. This graph is a lot less steep. It's still going to grow forever, but it's going to do that more slowly. Whereas in number 8, my original point is still the same, but I'm going to actually grow faster. So let's plug in a point again. Let's plug in 1. Square root of 1 is 1 times 3. Oh wait, look, that's way up here. I'm not going to plug in 2 or 3, but I'm going to plug in 4. The square root of 4 is 2 times 3 is 6. So I'm at 4, 6. This is a much steeper graph. See the difference? That fraction made me have a not so steep of a graph. The whole number made it go up a lot faster. That's what those numbers do. All right, before we do 9 and 10, let's look at 11. 11 is the same as 8 because if I have a number inside the square root, I want to take it out. The square root of 9 is 3. So this is 3 root x. It's the same thing as 8. All right, if I have a number in the square root, I want to take it out. So square root of 4/9, well, that's 2/3 root x. So that's what I'm actually graphing. This 2/3 is going to tell me like how fast I'm going up. So let's pick a couple points. Again, we're going to start at the origin. Now if I plug in 1, square root of 1 is 1 times 2/3. So I'm like here. I don't want to plug in 2 or 3, but I'll plug in 4. The square root of 4 is 2 times 2/3 is 4/3. So that's just a little bit over 1, a little bit above 1. So there's the growth on that. All right, hopefully that makes sense. So my domain and range for all of those is pretty much like it was on the front. The domain is 0 to infinity, and so is the range. Okay, this origin is at 0, 0. So the smallest x is 0, the smallest y is 0. It's going to be the same for all of these. That's the same. It's also the same for this. All of these where my graph starts at the origin have that same domain and range. The 9 and 10 are a little bit different. We talked briefly about what happens when there's a negative out there. Well, all that happens, like if I had y equals the negative square root of x, instead of being a graph that goes like this, it's upside down. That's all it's going to do. So number 9 is still going to start at the origin, but the negative 1/2 is going to make it grow slowly like number 7, but upside down, looking like that. Number 10, same as 8 almost, except upside down. So the origin is still the starting point, but now like plug in 1. The square root of 1 is 1 times negative 2, so it's going to go upside down. That's my graph. Okay, domain and range for this are still 0 to infinity, 0 to infinity, because my original point didn't change at all. It's still at the origin. Okay, so hopefully this makes sense. I did the answers. I'm going to post them now, and if you have questions, definitely ask.